welcome to Easy Elim Learning Simplified. My name is Ruth, and our topic for today is salt. So, previously we were discussing on preparation of soluble salts, and we said the two methods in the previous video was reacting of metals with acids and reaction of insoluble bases with acids. So, for today we are going to look at the next methods, the next three methods, and then we are going to see how those methods can be used, and then you tackle a few questions. So another method of producing soluble salt is the reaction of insoluble carbonate, hydrogen carbonate with an acid. So you can use a carbonate or a hydrogen carbonate, and it doesn't have to be soluble, it can be insoluble, as long as the product we are getting at the end of the day is a soluble salt. So how does this happen? So first of all, just like we said in the previous video, you're going to add excess of the carbonate or the hydrogen carbonate in a dilute acid, and you can use warm acid in the case where the process might be slow. And then effervescence is going to happen because there will be production of carbon dioxide. Carbon dioxide is produced when carbonates and hydrogen carbonates react with acids. And we get to know it's carbon dioxide because if you bubble that gas in lime water, it's going to turn to a white precipitate. So the reaction is going to be stirred until there is no more effervescence or no more fizzing, and that tells you that the reaction has stopped. And then the excess carbonate is filtered off, or hydrogen carbonate is filtered off. And then we repeat the same process. We heat the filtrate to saturation and we allow the crystals to form. And when they are formed, you wash them with distilled water and dry them between filter papers. So let's take a few examples of this process. So we can prepare a soluble salt, for example, magnesium sulfate, by reacting magnesium carbonate and dilute sulfuric acid, or magnesium hydrogen carbonate with dilute sulfuric acid. So we said that the steps are you add excess magnesium carbonate or hydrogen carbonate in a beaker containing warm. We use warm because it allows the reaction to proceed quickly. Dilute sulfuric acid, and then you stir the mixture until there is no more fizzing. And then next, you filter the excess magnesium carbonate or magnesium hydrogen carbonate, and then heat the filtrate to saturation and allow it to cool to form crystals. Then wash the crystals with distilled water and dry between filter papers. And someone might ask why we are washing the crystals, yet the crystals that have been formed are soluble in water. Will they not dissolve in the water? So when we are washing the crystals, we are not like putting them in a beaker and putting the crystals again and starting to stir. We're just passing some water very quickly on top of the crystals. That is to remove any excess like filtrate or excess solution that has not turned into crystals. We want to get the pure crystals. We want them to be as pure as possible. That's why we are washing with water very quickly, not dissolving them. And then we dry them very quickly between the filter papers. So if you write the equation, it's going to be magnesium carbonate solid, which react with dilute sulfuric acid, which is aqueous, to form magnesium sulfate, aqueous plus water plus carbon dioxide. So you notice that the reaction is balanced. You can see we have one magnesium this side, we have one carbon, we have 7 oxygens, and also this side we have 7 oxygens and one sulfur and one sulfur. This reaction is balanced. So that is an example of how we prepare, for example, magnesium sulfate in the laboratory. You notice the processes are the same. There's no much real difference from what we discussed from the previous lesson. So another method is the reaction of soluble bases or alkalis with dilute acid. Previously, we talked about the insoluble bases, which are in solid states, but in this case, now we are talking about the soluble bases. And these ones are in solution. So when it comes to this reaction, it's more or less the reaction that we are going to discuss later called titration in form 3. So you are reacting a certain amount or a known volume. You're not going to just react any excess base. We are going to use a specific volume of the base with a specific volume of the acid. And in this case, there are some things that you need to determine. If you are working with a mono acid and a mono base, and when I mean mono acid is, for example, HCl with one hydrogen atom, and then, for example, we are reacting it with sodium hydroxide, which is also monobasic, you notice that the ratio is going to be 1:1. Like when you write the equation, it balances out completely. You do not have to balance it. You notice you can use in this reaction equal volumes. But if you were to use sulfuric acid, and sodium hydroxide, you can see the sulfuric acid is diabasic. So the ratio is going to be 1:2. So in this case, every volume used for the acid, you have to double the volume of sodium hydroxide. So that is the reason why we are saying it needs to be very careful. And usually use a burette for this reaction, but you don't really need to use a burette anyway. You can get the known volume and you put them in different beakers and mix them, but it has to be a specific volume. Another thing that we do when we mix these two solutions, for example, when we are reacting hydrochloric acid with sodium hydroxide, for example, we need to add 2 to 3 drops of indicator. And the most preferably indicator that we use is phenolphthalein. The reason why we use phenolphthalein is because phenolphthalein has a specific color in acid and a specific color in base. Phenolphthalein usually is colorless in neutral solution and acidic solution, but it turns pink in basic solution. So if, for example, you add a few drops of phenolphthalein in 2 to 3 drops in a beaker containing the base or the acid, either way. Remember, the color is going to change depending on what you're going to get. We're going to start with a pink color. As we add the acid, slowly by slowly, the reaction is going to happen. At some point, that pink color is going to disappear completely. When it does so, it means that our reaction is complete. Other indicators also can be used with other alkalis, depending on their reaction. We're going to be specific later on when we get to form 3. So phenolphthalein indicator is pink in alkaline solution and colorless in acidic solution. The procedure is then repeated without the indicator. So we are going to after we have finished like the reaction, that is the HCl and sodium hydroxide, as after the reaction is complete, we will take now the final mixture and then heat the filtrate. We heat it to saturation because that is where we get our sodium chloride, and then we allow that solution to cool to form crystals, and then we wash those crystals between filter papers. So next we have direct combination of elements. So we usually do this reaction when it's not possible for us to do the other processes. And I said an example is when we are reacting with very explosive metals like sodium with acids. So an alternative that we can use is reacting these metals directly with the other elements. And in this case, for example, sodium chloride, we can use chlorine gas. So salt can be prepared by reacting a metal with an unmetal, and this is suitable for both. So it can be used to prepare soluble salts, and it also can be used to prepare insoluble salt. So when you come to preparation of insoluble salt, you're not going to repeat the same process, but just remember the same thing can be done for both soluble and insoluble salt. So for example, when a mixture of sulfur and iron filings is strongly heated, it glows red even when the source of heat is removed. This shows that the reaction between iron and sulfur produces heat. So we have iron and sulfur. You can see sulfur in this case is the non-metal and iron is the metal. So what happens if you take this mixture and you heat them, they usually glow, and then it produces a lot of heat and a black substance is usually produced. So the color of iron is gray and the color of sulfur is yellow, but the product that you get at the end of the day is going to be black in color. So the black solid that is formed is iron 2 sulfide, and that is the equation. So alternatively, in the case, for example, we were talking about reaction of formation of sodium chloride. So in this case, you're going to react sodium metal and chlorine gas. So in this case, we are going to lower a defragrating spoon in a gas jar containing chlorine. So what are we going to lower in this gas jar? So first of all, we are going to put a small piece of sodium metal, and then we heat it and we lower it quickly in this jar. And then we let the reaction occur. So alternatively, remember when we were discussing chemical families and how we were reacting metals with chlorine in halogens, we can also use the same process to produce the metals that we want. So this is the direct combination method. It's not that complicated. You just take the reaction directly. The gases which are very toxic, like the chlorine, is usually done in the fume chamber, or it can be done in an open space so that you ensure that like it doesn't cause issues in terms of toxicity. So let's look at a few questions in regards to the three methods we have just discussed. Describe how sodium chloride crystals can be prepared starting with sodium hydroxide solution. So we said that we are going to put equal volumes. So in this case now, equal volumes of sodium chloride and sodium hydroxide solution and hydrochloric acid solution are going to be measured. But first, before we mix them, first of all, we are going to take a fixed volume of sodium hydroxide is placed in a beaker and 2 drops of phenolphthalein is added. And then after it's added, then we add the acid, the hydrochloric acid, to this beaker until the reaction is complete. So remember, we cannot take this mixture. We cannot take this mixture. Remember, we have the phenolphthalein, we have the acid and the sodium hydroxide and the new product. So the new product is going to be water and sodium chloride. And remember, we still have phenolphthalein. So if we continue using this solution as it is, it's going to not give us the product we want. So we are going to repeat the procedure without the indicator. So you know the specific now volume required for sodium hydroxide to react with hydrochloric acid. Let's say you started with 20 centimeters cubed of sodium hydroxide, and then when the reaction went on and on, you realize you only require 15 centimeters cubed. I'm not saying this is exact, it's approximation. So it tells you that you only need 20 and 15 for the reaction to be complete. So what you do, you repeat the procedure again by taking 20 centimeters cubed of sodium hydroxide and adding 15 centimeters cubed of HCl, you are sure that the reaction is going to be complete. And then you heat this solution, the product, to saturation and allow it to cool to form crystals. And then wash the crystals with distilled water and dry between filter papers. So that's how that process is done. Do not forget, you take the fixed amount of the sodium hydroxide solution, you add a few drops of phenolphthalein indicator, in this case it's going to turn pink, and then you continue adding the hydrochloric acid slowly by slowly until the reaction is complete. You know that the reaction is complete when it turns colorless. So after that, you note down those volumes that you needed to react so the reaction can be complete. And then you repeat the process without the indicator, you get your product. And your product is going to be sodium chloride solution. So you heat the product because there is still water also in part of the product, it's going to evaporate and then you're left with the crystals after they cool down. So that's how you prepare sodium chloride using sodium hydroxide solution. This process, I said, is going to be repeated as we do titration in Form 3. So it is important for you to note it, although we have not mentioned some of the intricate details of titration. So this brings us to the end of the session. So don't forget that soluble salts can be prepared by 5 methods now: reaction of an acid with a metal, reaction of an insoluble base with an acid, reaction of a soluble base with an acid, reaction of a carbonate and hydrogen carbonate with an acid, and finally the direct synthesis where you react the metal and a non-metal to form the salt. So those are the methods. So next you're going to look at the preparation of insoluble salt, and we are going to look at that process in detail. So see you in the next session.